Now question is given in figure are examples of some potential energy function in one dimension. The total energy of the particle is indicated by a cross on the ordinate axis. In each case, specify the regions, if any, in which the particle cannot be found for the given energy. Also indicate the minimum total energy the particle must have in each case. Think of simple physical context for which these potential energy shapes are relevant. So for first graph, see, potential energy is positive. Whenever potential energy is positive, kinetic energy will be negative. So for this graph, it is when it is greater than E, then particle doesn't exist because kinetic energy is negative for the first graph, right? Now for B here, see, again potential energy is positive, that means kinetic energy will be negative, so graph doesn't exist for A to D, right? Then third graph, here A less than 0 and B greater than 0. For this particular instances, graph doesn't exist because for A less than 0, right, for that potential energy is positive, that means kinetic energy is negative. But the graph between A and B, so here graph between A and B for C, kinetic energy potential energy is negative, that means kinetic energy is positive, so we have particle in between A and B. And for the last graph, see here when potential energy is negative, so in between minus B by 2 to A B by 2 and minus A by 2 to A by 2, the particle exists in between this, but beyond that, right, because of a positive value of VO, that doesn't exist. So see here the graph which is 0 less than minus B by 2, right? So the graph exists only in between these two, minus A by 2 to A by 2, because there only we are getting negative sign, and till this also, because the kinetic energy is equal to total energy. So for these two only graph particle is exist, but 0 less than minus B by 2 and 0 here 0 greater than B by 2, particle is not there because potential energy is in positive, that means kinetic energy will be negative, so graph doesn't so particle doesn't exist for that.